Okay, so today we're going to talk about the square root property of quadratics. So what that means is that we're going to solve quadratics using what we call the square root property. But first, let's discuss and review different forms that we've dealt with, right? So there's standard form of a quadratic function, which is y equals, let's do a different color. So y equals ax squared plus bx plus c. That is standard form. It has the a, b, c, and it goes from largest to smallest. Okay, so second degree, first degree, 0th degree. Okay, then we have vertex form. So vertex form looks a little different. Vertex form is going to look something like y equals a x minus h squared plus k. So what these two have in common is they both have the same a value. Okay, so those two are different forms. You can have one of the same parabola, but it's written in two different forms. That is completely possible. We'll talk about converting from one to the other in a different video. And then we have factored form, which is y equals x minus x plus a, not a, I don't want to use a, x plus m, x plus n, which is what we've done in the past when we do the t-chart and we solve. So that's factored form. It's already factored for you. So these are the three different forms of a parabola, and we're going to be talking about solving when we have them in these two forms, but they have to be special types of standard form or in vertex form. Okay. Also, let's talk about different ways that we've spoken about solving parabolas. Actually, we'll talk about it in a minute. Yeah, let's talk about it in a minute. So, square root property. What is the square root property? So we know what a square root is. A square root, so if I take the square root of 16, it's going to equal 4. But in the past, we've spoken about how this symbol right here is actually the principal square root, which is the positive square root, meaning I don't get -4. I only get +4. However, what I'm really asking here is what squared gives me 16? Because 4 squared equals 16. But doesn't -4 squared also equal 16? Well, when I have this symbol, it means just the positive square root. So that's why I only give this. However, when we're solving, it's going to be a different situation. So let's talk about what the square root property is. So if I'm solving for x here, x squared equals 4. This is saying something squared is equal to 4. So the question is, what number, when I square it, do I get 4? So the obvious answer is 2, right? Because 2 squared equals 4, right? 2 squared equals 4. But what else squared equals 4? -2 is also, when I square it, I get 4, because -2 times -2 is equal to 4, because two negatives equal a positive. So it's not going to make much sense for me to just be like, all right, I'm going to take the square root of both sides, because this square root symbol means what? The positive square root. But here's the thing. When we are solving and we use the square root property, I'm going to put some room here. What we do is when we take the square root here, we are taking the plus or minus square root of both sides. This ensures that when I take the square root, right? So this cancels out. So this becomes just x. The square root undoes the square. They're inverse operations, right? So square root and squared, I'll do this, are inverse operations. The reason that this is the case is because they undo each other, right? So if I have 2 squared and I take the square root of it, what's 2 squared? I get the square root of 4, which is 2. It undoes this and this undo each other, and I get the 2 back over here. So they're inverse operations. Other things that are inverse operations, addition and subtraction, right? Multiplication and division. Those are all inverse operations. Okay? So we have x comes by itself, but then I have here equals the plus or minus, and what's the square root of 4? The square root of 4 is 2. But, like we said right here, it's 2 and it's negative 2. So it's not just one answer. So I get plus or minus 2, which is these two answers right here. So there's two answers. Technically, x equals 2 and x equals negative 2. There are two answers because both of these, if I were to plug it in, right, 2 squared is 4, and negative 2 squared is 4 also. So let's try this one. Now, we need to isolate the x squared. We can't just do this. This is the biggest mistake you can make. You have to first get the x squared by itself. So the first thing I'm going to do is I'm going to divide by 2. I'm going to get that x squared by itself. This goes away, and so I get x squared equals 9. And so what do? I have to get rid of that squared. So I take the plus or minus square root. And so I get x, so this cancels out. X equals plus or minus, and the square root of the principal square root of 9 is 3. I can keep it like this, or I can write it as x equals 3 and x equals negative 3. Or you can write it as x equals 3 and negative 3. These are all saying the exact same thing. Okay, so let's talk about using the square root properties to solve quadratics. So we just did it in 2, but I'm just showing you what the square root property is. Now, let me make some room here. This is another way to find the roots, solutions, zeros, or x-intercepts. If you remember, these are all the same word, right? Roots, solutions, zeros, x-intercepts. They're all the same thing for saying x-intercepts, essentially, right? And when we're finding the x-intercept, what is true about y? Y has to equal 0. So here's a little recap about what we've learned about solving. So these are different methods we have learned. Methods we have learned. One is factoring, right? Factoring plus the zero product rule. So example is something like y equals x squared plus 3x plus 2. What multiplies to 2 and adds to 3? It's going to be, and then first we turn y is equal to 0, right? So this becomes a 0 equals, and then this is x plus 2, x plus 1, because 1 times 2 is 2, 1 plus 2 is 3. Yes, I know I'm speeding through this because it's a quick review. It's not a lesson. And then you set each of these equal to 0. And you solve, and you end up getting x equals negative 2, x equals negative 1. 1 and 2. Another way we learned is the quadratic formula, which is x equals negative b plus or minus the square root b squared minus 4ac all over 2a, which is, we'll use the same exact thing. You will eventually get, if you do this, I'm not going to do it, but if you plug this in, you will get x equals negative 2 and negative 1. You can try it out, or you can take my word for it. But the point is that these are the two methods we've learned to solve, or we can graph it and then figure out what the x-intercepts are from there. But it's really important that we understand that when we're solving for x-intercepts, we have to make y equal to 0. So the square root property, I'm going to redo that. The square root property only works, boom, only works if it is in standard form with no b value or if it is in vertex form. You cannot do it any other way. It does not work. So, for example, here we have a quadratic function, right? This is in standard form. We have a is equal to, what's here? It is a 1. B is not there, right? There's no x term, so b is 0 and c is -9. We can use the property, okay? So let's do it. So first thing you want to do is you want to make y equal to 0. Y and f of x are the same thing. X squared minus 9. And then we have to isolate the square root. So I'm going to say plus 9, right? So I need to isolate the square root. And so I get 9 equals x squared. Then I just take the square root of both sides. So I do this plus or minus square root. Again, plus or minus always exists when we are working with solving. And so I get x on this side, this cancels out, and then plus or minus square root of 9 is 3. So I have x equals plus or minus 3. So I have so my x-intercepts are -3, 0, and 3, 0. These are my roots, or zeros, and these are my x-intercepts. Remember, roots are just x equals. X-intercepts are as points with y equals 0. So let's look at what that looks like on Desmos. So it was y equals x squared minus 9. Look at that. Y-intercept, -3 and 3. So it's really important that this gives me my x-intercepts, but I can only do it if there's no b value. So just like here, I have an a value of 5 and a b value of -500. So let's try it out. So first thing you want to do is set your y equal to 0. So 5x squared minus 500, and then I want to isolate my square. So the first thing I'm going to do, just like if this was an x, right? So if I had 0 equals 5x minus 500, first thing I'm going to do is add this 500 over. So it's the same concept. Isolating the x squared is the same concept of isolating the x. So I'm going to first do, I'll use red, plus 500 plus 500. This goes away, and I get 500 on this side equals 5x squared. Again, I want to isolate this x squared. So I'm going to divide by 5. This goes away, and so I get 100 equals x squared. I'm going to move this over a little bit. And then now I have the squared. I take the principal square root, but plus or minus. And so this becomes plus or minus square root of 100 is 10 equals x. So x equals plus or minus 10. Final answer. And again, if it asks for the x-intercepts, it would be 10, 0, and -10, 0. Okay, so what happens if it looks like this? This is in vertex form, right? But what's important here is it's technically not in vertex form. Vertex form would look more like this. Y equals x minus 10 squared minus 64, right? But they did most of the steps already for you. But I want to show you what it would look like to use the square root property on something that looked like this. Now, this is what's important here. You cannot touch any of this until you get rid of this square right here. Okay? Nothing inside is touchable until you get rid of the square. You cannot touch it. So what I have to do, and I'm going to keep it highlighted, and I'm going to write can't touch this. Da-na-na-na, da-na, da-na, can't touch this. Okay? Until you take the square root. There it is. Until you take the square root. I know you guys all miss my messy handwriting. So you can't touch it. So what I'm going to do, there's nothing else I can do, right? There's nothing out here to subtract, add or subtract, whatever. So it's already technically isolated. The squared term, this is what's being squared. It is isolated. So I'm going to take the plus or minus square root of this side and this side. Okay, so now I have on this side, this is easy, plus or minus square root of 64 is 8. But this side, all this does is cancel out the square. It does not affect the x or the minus 10. So it just becomes x minus 10 equals plus or minus 8. Okay, now you can go about this one of two ways. You can go about it where you split it up, just like the quadratic formula, where now I have, you see this plus or minus? I have x minus 10 equals positive 8, and then I have x minus 10 equals negative 8. So that plus or minus splits up right here. And then you just solve, right? I'm going to add 10 on both sides, right? This goes away, and I get x equals 8 plus 10 is 18. And here, if I add 10 on both sides, this goes away, and I get x equals 10 minus 8 is 2. That is one way to go about that. There's your two x-intercepts. The other way to go about this is, so if I have, same concept, x minus 10 equals plus or minus 8, I can add the 10 first. You see how we added the 10 here after? We can add the 10 first and then split. Either way, you either split, add the 10, or add the 10, split. So I get x equals 10 plus or minus 8. 10 plus 8, 10 minus 8. I'll even keep this in blue. Right? So 10 plus 8, 10 minus 8, 10 plus 8 is 18. And this is 2. So I get x equals 18 and x equals 2. Either way, you get the same answer. So let's try another one. How many more we got? 1 and 2. 2 more. So for this one, I'm going to highlight it. What is being squared? This whole thing is my square that I need to isolate. That 2 is not a part of it. That 2 is a coefficient. So I need to divide that coefficient out. Divide that 2, because this is technically being multiplied. So if I divide this 2, I get x plus 4 squared equals 32 over 2 is 16. Boom, I have this, but I cannot touch. Can't touch this, right? Like this is straight, can't touch this. Da-na-na-na, da-na, da-na, can't touch this. You cannot touch what's inside of the square until you take the square root. I hope when you're doing your work, you sing that and you're like, Mr. Suits, a crazy lady, but I don't care if you think I'm a crazy lady as long as you remember. Now we take the square root, plus or minus. So I get plus or minus, square root of 16 is 4, and this becomes x plus 4. Again, this cancels out the square. It does nothing to the inside. So again, method 1, we split into two different equations. X plus 4 equals positive 4. And x plus 4 equals negative 4, right? Plus or minus, plus or minus. And then you solve. Minus 4, minus 4, minus 4, minus 4. These go away. And so I get x equals positive 4 minus 4, so x equals 0. And x equals negative 8. And then we could do it the other way. So we have x plus 4, I'll write or, equals plus or minus 4. I can subtract the 4 first, and I get x equals negative 4 plus or minus positive 4. This negative 4 right here is the red. And so I get negative 4 plus 4 and negative 4 minus 4. Negative 4 plus 4 is 0, and negative 4 minus 4 is negative 8. So x equals 0 and x equals negative 8. Let's see what that looks like on a graph. So we have 2, y equals 2 times x plus, plus 4, x plus 4 squared equals 32. What are my x-intercepts? Negative 8 and 0. Oh, we're so good. We got it. I'm not going to go into singing. Don't worry. Okay, so let's go on our last one. So again, oh, what does this equal? This should equal, let's equal it to y. And we want to solve. We want to find the x-intercepts. Find x-intercepts. Yeah. Guys, it's most definitely 8:40 at night, so like I'm officially losing my mind. Okay. So we need to isolate what? What are we isolating? This whole thing that's being squared. So that means we need to x-nay this. Oh, this and this need to go away. But just like if I had something like 1/2 x minus 5 equals whatever, I'm going to add the 5 first and then multiply by 2. So it's really important that we understand our order of operations here. But first we want to turn this y into a 0, because when we're finding the x-intercepts, y equals 0. So I'm going to rewrite this. 1/2 2x minus 6 squared minus 5. So I'm going to do this first. So plus 5 plus 5. This goes away. So now I have 1/2 2x minus 6 squared equals 0 plus 5 is 5. Boom. Now, I need to get rid of this 1/2. I need to make it a 1, right? I essentially want a 1 up here. But what do I multiply 1/2 by to get 1? Or how do I cancel a fraction? You multiply by its reciprocal, which is 2 over 1. So I'm multiplying both sides by 2, or 2 over 1. This goes away, and I get 2x minus 6 squared equals 5 times 2, which is 10. Boom shakalaka. Now we have our squared, I forgot the word, our square term by itself. But guess what? Can't touch this. Dun-na-na-na, dun-na, dun-na, can't touch this. So we need to take the square root first before we can touch that. So x plus or minus, plus or minus. I didn't plan this out well. This wasn't supposed to be a 0 over here, but it's all right. We're going to let it rock right now. So we have 2x. It's going to be a irrational number. So 2x minus 6, right? Because this goes away. And then I get equals plus or minus the square root of 10. We don't know what the square root of 10 is right now, but we're going to let it rock. Actually, let's find out. What's the square root of 10? We're going to work with decimals here. I changed my mind. We're going to stick with the radical. So now we have to solve for x. We need to isolate the x. So we're going to start over basically. We're going to add 6, right? So now I have 2x, this goes away, equals 6 plus or minus radical 10. And then I'm going to divide by 2. And we get x equals 6 plus or minus root 10 over 2. This looks a lot like a quadratic formula answer, which is fine. So what we're going to do is so this technically, if I was just asking you to find what x is, that would be fine. But if I want you to find the x-intercepts, which I do, then you have to actually find out what it is. So this is going to be x equals 6 plus or minus, what is the square root of 10? I don't know. I don't know where square root is. Oh, here it is. Square root of, oh my God, what was it? Square root of 10. Boom. 3.16. 316. John 3:16, baby. 3.16 over 2. And now I can split, right? So here's my plus or minus, right? So this is my plus, this is my minus, right? And so now I have 6 plus John 3:16 over 2. And then I have 6. I'm just going to use this so I don't have to keep switching. So I have 6 minus John 3:16 over 2. I really got to stop making that joke. Okay. So this becomes 6 plus 316 is 9.16 over 2. And this is easy. This one's not as easy, but 6 minus 3 is 3, and then minus 0.16. You could put it in the calculator, but it's going to be 2.84 over 2. You could put this in a calculator and just divide it by 2. This is 4.5, and then plus 0.8, so it should be 0.08. So it's 4.58. Let's see. 9.16 divided by 2. Yeah, baby. And then this is going to be 1.84 is 42. X equals, boom. X equals, boom. So let's check it out. Watch, I'm totally wrong. Let's hope not. Let's see. 1.4, wait, where is it? 1.42 and boom, baby, 4.58. We got it, guys. All is well with the world. John 3:16. Thanks for coming to my TED Talk. Like and subscribe to my channel.